Welcome to Brain Vision.
Kind of an unusual coordinate system where the angle is measured from north. Instead, it's typically easier to think of angles measured from the east. And I'll show you an example of why. So I'm going to define the vector between Lincoln and Clarinda as LC. Okay, that vector looks something like this, where this is 85 degrees, and this is 5 degrees. So then we can see that the x component here is going to be 147 times the cosine of 5 degrees plus 147 times the sine of 5 degrees. So this is the I hat direction and the j hat direction, the unit vectors, which equals 146.6. Sorry, 146.4 I hat plus 12.8 j hat. So going from Clarinda to St. Joseph, we're going 167 degrees from north, so that's really negative 77 degrees from east. So if I call this 0 degrees here and we're going 167 around, then this is really just negative 77. So I can write this as 106 times the cosine of negative 77 I hat plus 106 times the sine of negative 77 j hat, which equals 23.8 I hat minus 103.3 j hat. And then finally going from St. Joseph to Manhattan. So 235 degrees. Again, we can do the same analysis. So that's 235 from north, which is the same thing as negative 145. So 235 is the same thing as negative 145 in real coordinates. So going from starting at east at 0, and where counterclockwise is the way that angles are positive. So we're going counterclockwise 145 degrees from 0. So we can write this as 166 times the cosine of negative 145 I hat plus 166 times the sine of negative 145 j hat, which just equals negative 135.98 I hat minus 95.2 j hat. Okay, so if we sum all of these vectors together, that will give us this vector here. So the vector addition will give us this. This is the sum. Okay, so the sum is 34.22 I hat minus 185.7 j hat. Oh. And the magnitude of the sum, so that's the length, how long the sum is, this vector sum, is just the square root of the squares of these two components, which equals 188.83. So this is the square root of the squares of 34.22 plus the square of 185.7, just from Pythagorean theorem. All right, so basically, to get back, we want to do the exact opposite of this sum vector. So the exact opposite, I'll call our displacement vector to get back, is negative 34.22 I hat plus 185.7 7 j hat. Okay, the length is the same. The length is still 188.83. That's how far you have to go to get back. And the angle, theta, will be the tan inverse of the y component, 185.7, over the x component, 34.22. So if I draw this vector, I'll draw it up here, D. It looks something like this, okay, where this is 34.22 and this is 185.7. And this guy here is theta. So the theta is the tan inverse of 185.7 over 34.22, which gets us 79.56. I'm going to call this theta prime because this isn't the true theta. Theta should start with 0 at north. So then we simply just have to add 270 degrees to this. So theta will equal theta prime plus 270 because we have to go. So if this is north here, we have to add this whole 270 degree angle to get our angle from north. And finally, we end up at 349.56 degrees.